My name is Ian Lewandowski, and I've been working in the scrap recycling industry for the past 20 years. I've been out in the field as a sales rep, I've been inside taking care of marketing, and I've worked as a manufacturer designing and manufacturing equipment. Today's topic is mobile shears. What is a mobile shear? A mobile shear, simply put, is a hydraulic attachment mounted on an excavator to process scrap in a scrapyard. There are different styles of mobile shears. One style is a rotating shear. It allows the operator to rotate the shear so that it can position it to get at the material that he or she is cutting. The other style is a straight shear. That, simply put, is a shear with no rotation. There are a couple different ways to mount a mobile shear. One is a third member mount. A third member mount is out on the end of the stick of the excavator. An excavator has a boom, a stick, and an attachment. If you take the attachment off and put a mobile shear on there, that would be a third member mount, and that's something a demolition contractor would need because they need to get up and have the most reach they can to get up at a building that they're cutting down, or a bridge, or a stadium, or whatever it might be. In a scrapyard, we don't need all that reach. What we need is to be able to put the biggest shear we can on the excavator to cut scrap that's piled up on the ground, that's easy to get to, that's right in front of the excavator. So in a scrap recycling facility, we would have a second member mounted shear where we take the stick and the attachment off of the excavator and mount the mobile shear to the boom, to the tip of the boom. The function of a mobile shear. The shear functions as a scissors. It's like any scissors. It has an upper and a lower jaw that bypass and cut the material. Pressure equals power. Pressure from the excavator equates to the power of the shear. Excavators offer up to 5,500 pounds per square inch of pressure these days. And that pressure equates to the power that the shear will have when it comes to what it can and cannot cut. If you have a lower pressure machine, the shear will have less cutting power. Flow equals speed. The more hydraulic fluid we can get to the cylinder on the shear, the faster it's going to be. A modern excavator has two main pumps. If we have one main pump feeding the cylinder on the mobile shear, it will give us a certain cycle time. A cycle time is how fast the shear opens and closes. That cycle time will increase quite a bit if we send the flow of hydraulic fluid from both of the main pumps to feed the cylinder on the mobile shear. That's measured in gallons per minute. Each pump will give us X amount of gallons per minute. And if we take both pumps and feed the cylinder on the shear, we're maximizing the speed that shear will be able to offer us, giving us the best cycle time. What can they cut? The shear power dictating what it can cut is, obviously we just talked about the pressure from the machine is a big component in that, a big factor in that equation. The other factors in that equation are the bore size of the cylinder. The bore size of the cylinder is simply the diameter of the cylinder. The bigger the diameter, the bigger the bore size of the cylinder, the more surface area we have for the fluid power to push on. The smaller, the less surface area we have to push on. The length of the cylinder, giving us a longer stroke. The length of the cylinder is going to be a big factor in equating what we can cut with the shear. If you think about a tire iron, the longer that lever is on that tire iron, when you apply it to a lug nut on a tire rim, the more force we're applying to that lug nut to tighten it or to loosen it. So the pressure from the machine, the bore size of the cylinder, and the length of the cylinder will equate to the force that we have at the tip, the apex, and the throat of the shear. These are the 3 points that we typically measure force to be able to determine what the shear can cut. When you're looking to purchase a mobile shear, your shear representative will typically be able to offer you an appetite guide. An appetite guide will show you in the guide what each shear, what different size shears have for force at the tip and the apex and at the throat. An appetite guide will also be able to tell us what the shear can typically cut, what it can pierce. How thick of plate can that shear pierce? What kind of material can it cut? What size I-beam can it cut? What size pipe can it cut? The last thing to consider when you're trying to evaluate what a shear can cut is the operator. The more experienced the operator, the more capable I tend to think that shear is going to be. The more experience an operator has, the more confidence they have to go after things that shear is capable of doing, capable of processing. Sometimes low confidence, you may not go after some things, and you just simply aren't going to cut things you're afraid to cut. But an operator can also make you more productive with that shear. When somebody asks me, how many tons of material will we have on the ground at the end of the day, at the end of that operator's shift? The best way to answer that question is to first introduce me to your operator. I'd like to know how good they are and how experienced they are with mobile shears. What do they cut? When you go to a scrapyard and you see a mobile shear cutting, it's a lot of fun, and it's one of the reasons I've loved selling mobile shears over the years. It's just a lot of fun to be around these things. It's really cool to see them do their job. You'll see I-beams in yards. You'll see the mobile shears cutting I-beams regularly, cutting pipes. You'll see rejected material from steel mills. They have a standard for quality, and they reject X amount of pipes or plate. If it doesn't meet that standard, you'll find a local scrap recycler cutting it up into small pieces to send back to the mill so that it can be reused. Farm equipment. You see lots of farm equipment accumulating generally in more rural areas. Manufacturing byproduct. We as a manufacturer, for example, cut the pieces we need to make our equipment out of a plate, and what's left is what we call a skeletal plate, and that plate gets put in a bin and gets sent to the local recyclers so it can be processed by, most times, a mobile shear, because it's some of the nastiest material, along with demolition contractors bringing structural steel from their demolition jobs to recyclers. That again is being cut by mobile shears, because mobile shears are generally what you're going to use to cut some of the nastiest stuff in a scrap recycling facility. Decommissioned vehicles, automobiles. You'll see mobile shears downsizing the automobiles, typically to go into a shredder, downsizing all kinds of different big things that may be processed by a shredder. You'll see them working next to a shredder a lot of times. And what you'll also see mobile shears cutting in the yards are maybe a decommissioned rail car. Maybe it's a rail car that's actually out on site. Maybe it's a derailment in the local community that where it's necessary to bring a mobile shear out to do that job. That's why we call it a mobile shear. It's mobile. It can go off site and do jobs somewhere else. For example, you may own several scrap yards, and you may only own a couple excavators with a couple mobile shears on them that you'll send out to one yard 1 week, to another yard another week. You may be even a contractor that does nothing but contract cut for scrap recycling facilities. Maybe you buy a few excavators with a few mobile shears mounted on them, second member mounts, and you go out and you cut for a large volume, very large scrap company that has several yards all over the place that chooses not to do it themselves. They hire a contract cutter with a mobile shear to come in there and do that job for them. It's really fun to see these mobile shears go off site and do like decommissioned ships. I've seen them cut up decommissioned battleships in a big harbor somewhere on the coast, or maybe it's a bunch of decommissioned barges or different boats, big large boats. It's really, really, really fun to see these shears go out and do these type of jobs. They're mobile shears that can be brought out to do a job just about anywhere that needs to be done. Maintenance. These shears can be maintenance intensive at times. You're going out and doing, like I've said several times, some of the nastiest stuff that you could ask a big hydraulic scissors to do. So that being said, there's moving parts on the shear. The pivot assembly for the upper jaw needs to be greased. Where the shear mounts to the excavator, the boom pin, the shear articulates, so that's a moving pin point where that's pinned, that needs to be greased. The stick cylinder that's connected to the top of the shears to articulate it needs to be greased. Typically what you'll see in the morning before an operator starts his day is to bring the shear down in a position where he can get to these grease points and grease them every day before he or she starts cutting with the shear. Wear parts. There are different areas of wear on the shear, and there's different ways to protect those areas, that parent material from wearing. And one way is a more traditional approach where you lay down beads of weld, hard surfacing beads with the grain of the parent material on the lower jaw, on the upper part of the lower jaw, and usually the underside the underside of the upper jaw. A more modern way to do that today would be what we call wear guarding. It's a 1/4-inch plate that's cut and contoured to fit perfectly on that mobile shear, and it's welded into place, and it protects the parent material, we think, even better than hard surfacing. Cutting blades. Mobile shears all have cutting blades and piercing tips. The way we used to go with mobile shears when it came to piercing tips was a weld-in piercing tip. A welded-in piercing tip would be a very lengthy process. There's a lot of heating and cooling to it, so it would tax the integrity of that upper jaw, of the parent material there in that area of the piercing tip. And back in about 2003, the bolt-on piercing tip was introduced, and that's what we use today. It's very easy to unbolt it and take it off and put a new one back on and bolt it in. And same for all of the primary and secondary cutting blades throughout the lower and upper jaw. They are bolted in and can be replaced. And the way that works is simple. The edge wears down over a period of time. On average, about 80 hours per edge. So that's about 2 weeks. Per edge that you're going to be able to cut with the edge of that blade. But what you can do once that edge wears down to a point, and with a gauge you can measure where you're at, and eventually you need to loosen the bolts and pull that blade out a bit and pop some shims in there, shim plates that have different thicknesses, and you can put more than one in at times, that bring that tolerance back nice and tight for the shear upper and lower to bypass with a nice tight tolerance. Because if we allow too much of a gap to be created there with wear, then we can start pulling material in and jam the shear. And shears have twice as much power closing than when they're opening. So it can be something that's easy to do if you allow that gap to be created. Once we have shimmed it to a point where we cannot shim it anymore, we simply unbolt that blade, take the shims out, and now flip the blade and pop and bolt it back in so we get the other edge. We get the other edge of the blade. And you can probably pop those shim plates in and keep the shim plates in. They're always going to be helpful to make sure you're going to keep in that tight tolerance. But what we have is a blade with 4 edges. So we can flip that blade and move it into different positions. They're indexable, so we can move them into different positions and maximize blade life by taking advantage of all 4 cutting edges, which again, generally speaking, depending on what application you're in, it can vary, but generally speaking, a blade edge has about 80 hours of edge on each edge, so that's going to last us about 2 months. The bolt-on piercing tip has about a 160 to a 200-hour life, so that's usually going to last for about 2 edges on each blade. So you're going to go through about 2 tips for 4 edges on each blade. That concludes our class on mobile shears. I'd like to simply add that the scrap recycling industry is an industry that I love working in. I'm passionate about my job for so many different reasons. I love getting up and doing my job. The main reason really is the industry I serve. I have dedicated a lot of my extra time to being part of the local Institute of Scrap Recycling industry chapters. I was elected recently to the national board for ISRI, and it's something that I like doing to give back to a trade association, to an industry that I have grown to love, because it's created a great life for me and my family, and it's just been a lot of fun. It's just been a lot of fun to do business with people in an industry that love what they're doing. And I know that given enough time, you yourself will come to love this industry and have as much fun working in it, and hopefully be as prosperous as I've been fortunate to be, not just financially, but mentally. I mean, it's just a great feeling to love what you're doing and love working in the industry that you serve. That concludes our class today on mobile shears.